Graphing tangent. We took sine and cosine over 2 days to first look at the general shapes of sine and cosine, and then on our second day to look at how we can move those graphs around. We're going to do everything with tangent on 1 day because moving tangent follows exactly the same rules as moving sine and cosine. So really what's new for us today is this new shape of tangent. But our rules for translating are exactly the same for tangent as they were yesterday for sine and cosine. Tangent looks completely different than sine and cosine. Tangent is not a wave function, but it is still periodic. So it does continue to do the same set over and over and over, exactly matching in each repetition. Tangent has things called asymptotes, though, that are lines that the graph approaches but does not touch or cross.
How far vertically do those go?
Infinitely vertically. When we graph tangent, we are going to plot 5 things, just like we plotted 5 things for sine and cosine, either middle up, middle down, middle, or up, middle down, middle up. We're going to plot 5 things for tangent. We're going to plot the asymptotes, and then we're going to plot 3 points of the function. A center point, halfway between that center point and the asymptote, we're going to plot a point, and halfway back, we're going to plot a point. The height of that point is going to be determined by A, just like our amplitude was for sine and cosine. We don't really say we have an amplitude of tangent because amplitude means height, and these things go infinitely up and infinitely downward. So we can't really call it a height, but that A value still does determine something, and it's that height of the point that is halfway between the center and the asymptote.
Asymptotes for tangent of x on the little notches here?
Yes. In this graph, those asymptotes would be where the notches are. The period of tangent is the length between those 2 asymptotes. The rule for the period of tangent is pi divided by b. For sine and cosine, it was 2 pi divided by b. Tangent repeats every pi divided by b. Tangent is a faster moving graph than sine and cosine. That is the major difference that you need to remember when it comes to our test on this. That's where students will often make a mistake and just do 2 pi over b for everything. Tangent is just pi over b. Our asymptotes will be located at half of the period. So we'll find our period length by pi over b, and then our asymptotes will be located at half of that period. So we're going to begin by considering the same types of things. We don't need to think about shape because tangent has its own distinct shape. It's different than sine and cosine, so we don't need to think about shape. I use the word amplitude here, but it's not really an amplitude. It's still a height definer, but it's not technically the height of the whole function. But nonetheless, that 3 halves determines the height of that point that will be halfway between the center and the asymptote. The period is pi divided by b. What is b? 4. So our period is going to be pi fourths. The asymptotes are located at 1/2 of the period. So we take our period of pi fourths and multiply it by 1/2, and we get pi over 8. Questions?
Yeah, is the period the length between the
The period is the length between the asymptotes. Question?
Why don't we do pi? Why don't we do b times 2? Because for the period we just did pi over 4.
Yes, the period is just pi over 4 because the rule for tangent is pi divided by b. Sine and cosine was 2 pi divided by b, but for tangent it's just a plain pi divided by b. And then for our asymptotes, we multiply that period by 1/2. Pi over 8 is really tiny. So if you think about taking the 3 lines of the paper, tipping, calling a pi, and then having to break that down into 8 pieces, it's going to be really tiny. So I'm going to adjust my scaling on this one. First thing to consider, when we do tangents, we will care about the negative of the x-axis as well. So I'm going to put my y-axis over a little bit further than we have been. Then to adjust my scaling on this one, since things are going to be so tiny, I'm going to count by halves on my y-axis so that when I tip 3 lines of paper, instead of calling it a pi, it's just going to be 1/2 of pi. I'm kind of zooming in on this picture so that stuff won't be so incredibly tiny. Then for tangent, we care about the negative space as well. So I'm going to go backwards to negative pi halves as well. The first thing we plot in our tangent graphs are asymptotes. The asymptotes are located in this problem at pi over 8. So what I need to do is take that pi halves and break it down into 4 pieces. And each of those pieces would be 1/8 of pi then. So my asymptotes go at the 1/8 of pi on both the positive side and the negative side. Then we plot 3 points for tangent. We're going to plot a point right in the center at the origin. Then tangent is nice and symmetrical, so things break down by halves. So halfway between that origin point and the asymptote, we're going to go up or down to that a value, which is 1.5 this time. So that's 3 lines of paper, since we were counting by halves. Halfway between the origin point and the asymptote. Half the distance horizontally between the origin and the asymptote. And then we connect those points. And the line of the tangent graph should just follow along those asymptotes, never actually crossing it. Those asymptotes just guide it along. As with sine and cosine, I would like to see 2 cycles. The width between these asymptotes is 2 dashes, so I'm going to go over 2 dashes and put another asymptote. And repeat the same 3 points that we did for the first cycle. Questions? Yes, please do 2 cycles again, just like we did for sine and cosine. This example will not be so squishy, so it'll be a little bit easier to see stuff that's going on here. So we don't need to consider shape. Amplitude isn't exactly the right word, but that a value still determines a height, and that height is going to be 3. Period for tangent is pi, not 2 pi, just pi, divided by b. What is b in this question? 1/2 of pi. How do I divide by a fraction? Multiply by the reciprocal. So I get just 2. So in our scaling, we're not going to care where pi is. We're just going to count by ones. And our asymptotes are going to be located where? At 1. Half of the period is the location of the asymptotes. So I'm ready to create my axes. Leave yourself some room on the negative side for tangents. I can still take 3 lines of paper and tip it, but instead of calling it a pi, I'm going to call it a 3. First thing we put on our graph for tangents is the asymptotes. The asymptotes, it says, are located at 1. And then symmetrically also at -1. Then we plot 3 points. We're going to have our origin right in the center. Halfway between that origin point and 1, where the asymptote is, we're going to be up the amplitude value of 3. And halfway back to the other asymptote, we're going to be down at 3. Question?
Why did you go up to 3? I know the height is 3, but why did you go out?
Because you have to go.
Because I'm going to need to do 2 cycles, and so I just kind of knew where my next cycle would end. You can always just add on more. So if you didn't go all the way out to 3, that's fine. You can just add on, but I knew that that's where my second cycle was going to end. I also just always grab 3 lines of paper and tip it, and I either call it pi or I call it 3. So to get the second cycle, we look at the width between the asymptotes. Between the asymptotes has a width of 2, so I go over 2 more, which does put me at that 3, and make another asymptote, and copy over the same 3 points of the pattern. Questions? I'm going to do some jumping ahead to where it says translations and reflections. I'm going to skip the next couple and go to where it says translations and reflections. The rules for translations, which just means shifts, and reflections, which means flips, are the same as they were for sine and cosine. So adding or subtracting is going to move our graph in the same way that our graphs moved yesterday, either vertically or horizontally. So in this example, what is that plus pi fourths going to do to our graph?
Push it back, pi over 4.
It's going to push it back to the left, pi over 4. When something was added or subtracted, grouped in with the x yesterday, that created a horizontal shift. And horizontally, we do the opposite of what it says. So if we're adding, we go back to the negative. If we're subtracting, we go to the right to the positives. So we're going to go to the left of pi over 4 here. Question?
What makes a vertical shift?
A vertical shift would be an adding or subtracting that is not contained within parentheses. So if there's something added or subtracted, parentheses present.
Is that opposite too?
No, vertical shifts do what they say. So up, down, if we're adding, we go up. If we're subtracting, we go down. The amplitude or the height value for this one is going to be what? 1, but there is a negative here in this equation. What did those negatives do yesterday as a negative a value? It flips it so that our ups become downs and downs become ups. So what that means is our graph this time is going to begin upward and head downward. So it's taking that graph and flipping it upside down, just like negatives did to our graphs yesterday, switching ups to downs and downs to ups. It's going to do the same thing here. So instead of our graph heading upward, our graph is going to head downward. The period is pi divided by what? 1, because there's no number going from the x. So the period is pi, which means that are where? At a half of pi. Okay, so now we're ready to draw some axes and get some scaling here. Remember to leave yourself some room on the backward side of our tangent graphs. Take 3 lines of paper, tip it, call it a pi, and also go backwards to a negative pi. The first thing you should always take care of before you start plotting anything is any shifting that occurs in the graph. So this graph is supposed to shift to the left pi over 4, or a fourth of pi. So I need to divide these pi's into 4 pieces. And I'm going to move backwards to the left one of those pieces. Now, since we're using dotted lines to represent asymptotes and shifts, that can be awfully confusing. So I'm going to label this underneath there that is my shift line, or my starting line. So then the first part of my graph that I plot is asymptotes. The asymptotes are supposed to occur pi half away from our starting line. Well, how big are each of the marks? A fourth of pi. So if I need to go to a half of pi, how many marks away do I go? 2 of them. 2 quarters makes a half. So I'm going to go 2 markings away and make my asymptotes. So 2 markings away from that starting line, I make my asymptotes, because 2 quarters is a half. And I need to go to a half of pi. Then I plot my 3 points. I plot my center point right on that starting line. Halfway between my center point and the asymptote, I'm going to go to the amplitude value of 1, but this is upside down. So on the right-hand side, it's going to be down 1, and on the left-hand side, it will be up 1. So the graph begins upward and heads downward.
So we should always start the graphs really close to the asymptotes? Like
Yes, the graph, the line of the graph should be approaching the asymptotes so that those asymptotes act as a guide for it. Now we need to repeat this shape over one more time. How far are these asymptotes away from each other? 4 markings, right? It's a length of pi, and each of our markings is a fourth. So I need to go 4 markings over. I only have 3 more markings, so I need to bring in 1 extra little marking. So I can go 4 markings away to make my next asymptote, and then repeat the shape. Questions? What is that -2 going to do to our graph that's in the front of it?
Shift everything down.
How do I know that that's not my a value? Because there's a plus there. It's not multiplied. An a value should be multiplied. It should be right next to the word tangent. If there's anything else between them, it's not the a value. So this is something that's added or subtracted with the equation. So that's a vertical shift. Verticals do what they say. So this is going to move our whole graph down 2 spots. What is that minus pi halves going to do? I'm going to go to the right pi over 2. Something that's grouped with the x is going to move along our x-axis, and it goes opposite of the sign that's indicated. What is the a value that would determine the height or amplitude? 1. There's nothing multiplied in front of the word tangent. And the period of this graph is going to be pi divided by, what's b? 1, because there's nothing in front of the x. So the b value is the multiplier of the x, and there's nothing there. So our period is just going to be pi. Which places our asymptotes where? At pi over 2.
Shouldn't the amplitude
The amplitude is determined by the multiplier of tangent, and there's no number right in front of the tangent, so there's a 1 there. That 2 is a shift. It was added. My circles kind of went over the plus there, but it was added. All right, so we have all of our guiding information here. So now we're ready to draw some axes and do some scaling. First thing I always take care of before doing any of the plotting of the actual graph is the shifting for the graph. So we need to move this thing down 2 units, so down 2 lines. I'm going to have a new midline. And to the right, halfway to pi, I will have a new starting line. So after I've taken care of any moving for the graph, then I'm ready to plot the asymptotes and the points. The asymptotes belong pi halves away from the starting line. Where will that place them? If I put my asymptotes pi halves away from that green starting line, where will they be? On pi and on the y-axis, because our markings each represent a half here. Then I plot my center point, which should be right at where those shifting lines meet, right at the middle and right on our start line. Our amplitude, our A value is 1, so that means as I go halfway between my origin point and my asymptote, I go up a height of 1, and halfway back down a height of 1. You need to do 2 cycles. You could create more markings and continue this on out to the right-hand side, or since I already have markings over on the left-hand side that I haven't used yet, I could make my second copy back that way. It doesn't matter because it continues doing the same thing forever in both directions. So if I use the markings I already have, my 2 asymptotes are pi away from each other, so I can go back to that negative pi and put another asymptote and copy my points.
Well, so you can choose where you want to go.
Yep, you can choose to go and use markings you already have, or you could choose to just keep on going in the right-hand direction and extend your markings on out to 2 pi and make your copy in that direction, because it would be the same either way. You don't need to do both. You can choose one or the other. We just need 2 copies, but it doesn't really matter where that second copy goes.
How do you know when to flip it?
You flip it when you have a negative A value, so when there's a negative right in front of the tangent or the sine or the cosine. We're going to jump to the last question. As with our last example yesterday, this is the one that's got everything going on here. So, I have a negative in the front. What does that negative in the front do? That's our flip. When there's a negative right in front of the trig name, whether it's sine, cosine, or tangent, that's our flip. So this one's going to start up and end down. As I just kind of work on through here, what's that 2 going to do? What does that change? The period. That's our b value. So our period is going to be pi over 2. Which means that our asymptotes are going to be where? Pi over 4, 1/2 of the period. As I continue kind of working through the stuff in the problem, the next thing I come to is the minus 3 pi over 4. What's that going to do?
Shift everything to
That's going to move us to the right 3/4 of pi. And the last thing in that equation is the plus 1. What's that going to do? Move it up 1. Since that's an addition that happened outside of parentheses, that's a shift that moves us up or down. So I've worked my way through the whole equation now, so now I'm ready to start making myself a graph. Make the axes. Make the scaling. And before I begin plotting any parts of the actual graph, like the asymptotes or the points, we need to take care of any shifting that will occur. So this graph needs to move 3/4 of a pi to the right. So I need to take that pi and cut it into 4 pieces. And I need to move over 3 of those pieces to the right. And that creates my new starting line. I also need to move up 1 line, and that creates my new middle line. Then the first part of the actual graph that I plot are the asymptotes. The asymptotes should be pi-4ths away from the starting line. So how many markings will that be? Just 1 marking, because each of those markings represented a 4th. So I'm going to go 1 marking away each side of that starting line and make asymptotes. The center point will be right where those 2 shift lines meet each other. The middle line and the starting line will always be a point right there. Then this graph had an amplitude value of 1, but it was flipped upside down. So as I go to the left, I go up, and to the right, it goes down. Now I need to create 1 more copy of this, and I don't have any more markings out to the right. I could make more markings, that's fine, or I've got tons of markings over to the left that I haven't used yet, so I'm just going to go back and use those. How far apart are my asymptotes? Pi over 2, because that's the length of the period, which is 2 markings. So I'm going to go back 2 markings and make another asymptote, which puts that right onto the original axis. Copy the same 3 points and repeat the shape. Questions? Your homework is from 14.1 and 14.